Today I'm going to be talking with you, as I'm sure you're already aware, about real-world design considerations for punching shear and flat plate slabs. I want to remind everybody that if you do have a question along the way, please feel free to enter that in the Q&A box, and we will pick them up as we're going along. I want to start by giving you just a basic overview of what we were doing. So some background on punching shear. I'm going to talk generally about punching shear as a phenomenon, what is actually going on. I'm going to talk a little bit about the models that the building codes adopt for how to assess the demands from punching shear and how to estimate capacity, or how to develop design capacity, I should say. And then I'll talk about some specific issues that are related to either construction practices or typical issues you run into during design that will impact the capacity of particularly elevated flat plate slabs, but some of these issues also play into foundation design as well. And then we'll go through a couple of examples that deal with consideration of opening effects and consideration of tolerances, just so that you can see some of the ways that those can be approached. And then, of course, there'll be a brief summary at the end when we can discuss what it is that we've, tell them what you told them, and then make sure that you guys have any questions. We can cover those at the end. So jumping on to references. I put these in here for two reasons. One, so that you had an idea of what it was that I looked at in putting together my presentation, what I've used as references for a variety of design projects in addressing these. And I want to emphasize the the document numbers in bold, so the 117.10, 318.14, IBC 2012, so forth. Those are the documents that were primarily used as references when I talk about the code says or the specification indicates. Those are the documents I'm primarily referring to. I also have some additional references that are more technical in nature that we'll mention as I move through, but I wanted to make sure that I gave everyone the information that's involved so that if you have questions, you want to look into that in more depth, you can do that. So as an engineer, I sort of have some sort of an obligation, or maybe it's just me, to make a Princess Bride reference every so often. So today, you guys get the benefit of my Princess Bride references. So in the Princess Bride, they talk about the two classic blunders: never get involved in land war in Asia, and never go against the Sicilian when death is on the line. And I would like to introduce a third classic blunder, which is never underestimate the potential for punching shear problems. When you go in and you design your column and your slab for that connection, and you say, oh, okay, well, this is the amount of load I'm transferring, and hey, I don't have any openings there, you might have permitted an opening to be placed using the typical detail here, or you might have had an opening added by RFI, or you might just have had both of those come in at the same location. Maybe you're close to a slab edge, and the program's not picking that up when you're doing your checks, or your hand back check didn't catch all of those. So it's important that you take those into account as you're moving along. So next question is, what is punching shear? Let me get rid of that pointer there for you. So what is punching shear? Punching shear occurs essentially due to the shear transfer demand between the elevated slab and the column supporting that elevated slab. And the punching shear occurs when that shear transfer demand, or at a concentrated load, exceeds the capacity of that connection. Right? It's a relatively straightforward concept in terms of what happens, right? But it's important to remember that as you're considering this, you don't necessarily have to consider some of the loads that are immediately adjacent to the column, right? Your slab is actually going to break away from the column, and we'll talk about it more in detail, but once you're within that assumed punching shear radius, you can discount a fraction of that load. In general, that's not going to be enough to make a substantial difference in your design, but I did want to bring that up. So what does punching shear look like? This is an example from an earthquake in, I believe it was New Zealand, in which a parking structure, an older parking structure which had fairly minimal detailing. You can see in the tops of these columns that the extension of the bars was very short. Right? You can see here, those are the top bars that were present. You can see that there's essentially no continuous bottom steel which would be called for by code. So there's very little redundancy, and you can see here the truncated cone, the typical punching shear failure.